Hey, all right. All right. So I told you I was going to go over this with you again. I'm going to go over this quick, though, okay? Um, you should all listen, you should all have these done. Those should all be in your notebook. Pretty easy. I went through every one of them. I will go over five um, quickly. So initially, I said that was 0.229, but yeah, I looked at it a little closer and it's not quite on the nine. So I would call it 0.2285 or 87. I mean, you know, close enough. It's all right. Moving down to six, it says record the dial pin size you recommended for this blind hole. And so if you picked quarter inch or 6 millimeters, you're okay with that. All right. So not a big deal. 6 millimeters or quarter inch. Then I plotted all these. You should have this. I put this in the announcement. I put this Excel sheet in the announcements, and um, I got I was able to get everything out of that. So for number seven, the mean that I got was 2.364. That's for A, 2.364. And then you plot a histogram, okay, and which is in the Excel. And so the standard deviation I got was 0.00.18. Okay, 1817. So there you go. And then C says, based on the data, what can you infer about the accuracy? Um, well, for a 6 millimeter pin, conversion to inches would be 0.2362. The accuracy is the difference between the measured value and the targeted or accepted value. Okay, so the printer is producing holes that are if you subtract 0.2364 minus 0.2362, you get 0.0002 inch larger than the target. All right, and then I did the same for the quarter inch up here, and you would get that. Okay. All right. Okay. Um, so number 8. So if we look at number 8, and it says write a bilateral tolerance. For number 8, I would put 2.364 plus or minus 3 times the standard deviation would equal, which is 0.001817. Okay, is the standard deviation. So you would then say 0.2364, which is the mean, plus or minus 3 times 0.0017 gives you is equal to 0.2364 inches plus or minus 0.0051 inches. Okay, so and then that's that. Okay, and Then it says use the mean and standard deviation, blah, blah, blah. And then you would do the same for 95%, which is 2 standard deviations, and 68%, which is 1 standard deviation. Okay? And that's it. I mean, that's do it the same way. It says you can use the empirical rule to justify your response, accept any reasonable claim for this problem. Hole sizes smaller than the mean, right? 50% of the sample data will result in a snug fit. So that's what you could put for there. And then this is for 8. I'm sorry. This is for 8. I'm sorry. 8 was here. So I told you how to get that. All right. It's 2.2364 plus or minus 3 standard deviations times the standard deviation that we got, which was 0.00. And then you'll just explain the empirical rule. And you don't have to go into heavy duty depth. Here, these are the answers for 5 millimeter for that video for 7 and 7/32 of an inch pin, and 6 millimeter pin, and the 1/4 of an inch pin. And number 10, I was hoping you'd be able to do that. You know, you could say something like the outside diameter of the dowel pin impacts the ease of rotation of both the pin within the corner guide block and the rotation of the block about the pin. So really you could put, based on these, you know, and I kind of like to just hear your summary about that. So that's that. And that's it for right now.